In problem number 3, we've got Stephanie and Alexandra paddling upstream. They paddle upstream for 2 hours and then they paddle downstream for 3 hours. The rate of the current is 2 miles per hour, and then they stopped and they realized that they were still 20 miles downstream from their starting point. How many hours will it take them to paddle back to their starting point? Alright, the key to this problem is to understand relative motion. So when these guys paddle their canoe, they're paddling at a certain rate with respect to the water, okay? But the water is flowing in a certain direction at 2 miles per hour, okay? So the water is pushing them back at 2 miles per hour. So if they're paddling upstream, let me write that out, paddling upstream, their speed will be, let's say that their speed with respect to this water is x. Okay, so I'm going to say x is equal to their speed with respect to, I'm going to abbreviate that, the water. Okay? So x is their speed with respect to the water. And when they're paddling upstream, their speed is x minus 2, because the water is pushing them back. Okay, so like if you put this canoe in the water and didn't paddle at all, it would just float downstream with the water, right? So it would go 2 miles per hour without paddling at all. And then when they start paddling, they start overcoming the speed of the water, and so they paddle with respect to the water, but with respect to the land, their speed is going to be 2 miles per hour less. Okay, so paddling upstream, their speed will be x minus 2, and paddling downstream, okay, their speed is going to be increased by the speed of the water, okay, because they're pushing with the paddles, but also the water is just naturally flowing in that direction, so it's going to help push them along. So their speed is going to be x plus 2 with respect to the land. All right, and we're interested in their position and their speed with respect to the land because we want to get them back to a point on land where their starting point where they started. Okay, so let's work with that. So what do we know? How far are they going to go when they go upstream? They paddle upstream for 2 hours, and we know that distance is equal to rate times time. That's just kind of a that's just sort of a given. So if they're paddling at x minus 2 miles per hour, and they paddle that for 2 hours, they'll go a certain distance. We'll call that, I'll just write that out. This is the distance when they go upstream. Okay, it's going to be x minus 2 times 2. Okay, and I guess we have to kind of have a reference direction. We're going to call upstream positive, and we'll call downstream negative. Okay, because here the positive and negative does matter, because when you turn around and go downstream, so now we're subtracting from their distance upstream. So we're going to subtract this. They're going at x plus 2 miles per hour, and it says that they go downstream for 3 hours. Okay, so the total distance that they cover is going to be x minus 2 times 2 hours. Alright, so their speed times their time. And then we're going to subtract, because they've turned around, they're going in the opposite direction now. And so they're going back to where they started from and then some. So their speed is x plus 2 miles per hour, and they go at that rate for 3 hours. So and they end up 20 miles downstream from where they started. And we said that downstream we call that negative. So we're going to say that they end up at a minus 20. Alright, so we're 20 miles downstream from where we started. Um, so we have an equation now. So we've gone at a certain rate upstream, and then we've turned around, so we're going the negative direction. We go a certain amount downstream, and we end up 20 miles downstream from where we started. Okay, does that make sense? And you know, key thing is that, you know, the signs too are important, right? So you need to know why that's negative. It's because we started at a certain point and we went upstream, and we just chose that as the positive direction. We could have chosen it the other way, but then when we went upstream, we'd actually be going in a negative direction. Okay, so, but if you think about it in terms of, you know, you go a certain distance upstream, and you know that when you turn around, you're going back from where you toward where you started from, and so you have to subtract that distance. And then if you go further than where you started from, you start going negative, right? If you go further downstream from your starting point, okay, you're going less than 0, okay? so you're negative. So now really all we have to do is solve this equation, and that's not too bad. We'll use the distributive property here, and we'll multiply through by this 2, so we get 2x minus 4. And here I'm going to use the distributive property twice. We have a negative sign, and that has to be distributed inside the parentheses. And also this 3, okay? So I could do it in one step. I could say negative 3x minus 6. Okay, so you see how I got that? You could think of it as a negative 3 being here instead of here. And then taking negative 3 times x and negative 3 times 2. Okay? And that should be equal to a negative 20. And then, let's see, we have 2x minus 3x, so that's a negative x. And then we have negative 4 minus 6, so that's a negative 10, is equal to negative 20. Alright, scroll down a little here. And, alright, so I like positive x's, so I'm going to add x to both sides. So we have an x over here, and I'm actually going to add 20 to both sides as well. So x is equal to 20 minus 10, so that's 10. Okay, now what was x? X was the speed with respect to the water of their paddling. Okay, so this is 10 miles per hour. That's how fast they paddle with respect to the water. Alright, but that's not what they asked for, is it? They are asking how many hours will it take them to get back to where they started. Okay, so we got to do a little more work to figure that out. But we know that they're going 10 miles per hour, and they've got 20 miles to go. But we have to take into account the speed of the water. So let's take 10 minus 2, alright? Because with respect to the land, they're actually only going to be going 8 miles per hour. And if we were to take that times t, then we would get the distance, and we know they have to go 20 miles. Okay? So we know that 8t is equal to 20, and so t is equal to 20 over 8, or that's 10 over 4, or that's 5 over 2, which is equal to 2.5 hours. Okay? Does that make sense? Now you notice here I didn't use a negative here because I could have said this was a, you know, if we're going upstream here. Actually, that's not. So we're going upstream now. So we want to go in the positive direction. So here we were 20 miles downstream, but we want to go 20 miles back upstream. Okay, so that's why we're using the positive here, in case that confused you at all. But so we're going upstream, and so the sign is positive. All right, so 2.5 hours is the answer.